Hello everyone, welcome back to this series on deploying and managing containerized workloads in the cloud. As Karan mentioned, this is the third of the 6 webinars that we have lined up for you. And the first 2 webinars primarily focused on getting you up to speed on containers. So if you're joining us for the first time, you can still catch up with the flow, but it would be very, very useful and helpful for you if you can go back and take a look at the first 2 episodes of this series. The objective of this series is pretty simple. We want you to get extremely comfortable with containers and learn Kubernetes to manage those containerized applications. The first webinar was all about installing Docker and getting up to speed with core Docker architecture and commands. The second webinar was focused on containerizing your existing applications. We took a Node.js application and containerized and deployed it. I introduced the concepts of Docker Compose and scaling those containers using the Docker Compose CLI. But starting this part, it is going to turn exciting because we are going to move into the actual essence of this entire series, which is Kubernetes. I covered just enough Docker that is sufficient for you to understand Kubernetes and establish a relationship between containers and Kubernetes. So this is when we'll actually start putting some of those concepts to use. And starting this webinar, you will learn everything that you need to know about Kubernetes. So I'm pretty excited. I hope you are as excited as me. So let's get started. The agenda for today's session is the changing phase of data center. I want to touch upon the transition from virtual machines to containers and how it is actually affecting the data center. And then I'm going to introduce you to Kubernetes, which is a the front and center of this transformation and managing the microservices and the containerized workloads. Then we'll actually take a closer look at setting up the Kubernetes cluster. Even if you're not very familiar with DigitalOcean, or even if you're not very familiar with systems administration and playing with command line tools, you'll still find it very easy to install and configure a Kubernetes cluster. So this is going to be an interesting mechanism to get a cluster up and running. So I'm going to walk you through that. And then we'll configure and explore the dev environment. On your local machines, you can actually configure a couple of tools which will point you to the cluster that is running in DigitalOcean. In that process, I'm also going to walk you through the Kubernetes CLI. And again, these steps are available as a part of the tutorial. The entire script that I'm going to use will be made available on the tutorial, so you can go back, copy and paste and run exactly the same set of commands. And finally, to ensure that the Kubernetes cluster is actually set up the right way, we'll also deploy an application and access it. And that is going to verify the entire installation. So let's get started. The changing phase of data center. I'm sure most of you are familiar with virtualization and VMs and how it has taken over the physical data center. But interestingly, in the last 12 to 18 months, we have seen a fundamental shift in the data center where the deployment unit is moving away from a physical machine or a virtual machine to more of a container. Many applications are getting packaged, deployed, and managed as containers. And in the last 2 webinars, we extensively focused on Docker and how it containerizes an application. So we are talking about applications getting packaged and deployed as Docker containers. The infrastructure in itself has become immutable. What it means is no one is spending time fixing broken VMs. It is more expensive to SSH into a broken VM and fixing it rather than launching another one and trying to terminate the faulty one. So infrastructure is not going to be changed very often. You are going to make it very repeatable and immutable. Immutable is once an infrastructure is set up, it is not going to be modified, which means you are not expected to log into one of the VMs or one of the droplets and exclusively work on fixing it. It is not a worthy effort. Instead, you are expected to create a standardized image, test it thoroughly, and then roll it over to production and only focus on scaling it rather than fixing individual VMs. If more than one VM is failing, that means there is a fundamental problem with your original image that you are using as a template to launch your infrastructure, and you got to fix that, but not one of the running instances. So that concept is basically called as immutable infrastructure, where you will focus more on repeatability, reusability, composability, and scale rather than dealing with one VM at a time. There is an emphasis on treating the data center as a large server. If you look at a physical or a virtual data center, whether it is running on premises or in the cloud, you have a set of machines, again, physical or virtual machines. And these machines or resources come with some CPU cores and some amount of memory. Today, in its current form, it is very hard for you to exploit the last bit of performance from the collection or the aggregated set of resources. In majority of the cases, you'll actually notice that while your database server is overutilized, it is almost at the verge of giving up because it is at 90% utilization. And then you will actually notice that there are some machines that are not even utilized 30%. But unfortunately, you're not able to balance it because they run very different set of workloads and they are not really created as a pool. With immutable infrastructure and the new capability that we're going to explore, we are going to treat the entire data center as one large server. So if the database workload is expecting 90% utilization during the peak hours, that's not a problem because it will be automatically rebalanced and the workload will be spread across the data center by making use of the pooled resources. So we are not talking about one VM or one physical machine, but we are talking about a collection of machines and an aggregated pool of resources that will be collectively used. And this is going to result in optimized utilization and better efficiency of your infrastructure. At any given point of time, your entire infrastructure is utilized in the most optimal way without either one workload exceeding the CPU utilization and the other are below expected utilization. You will never see that because you're going to look at the overall aggregated pool of resources. The tools that are typically used to manage the new data center infrastructure, which is treated as one large server, Docker Swarm, that is one of the very simple, easy to use tools. Kubernetes, which is the focus of today's session, or you could also use Mesosphere's DigitalOcean. So Mesosphere is another open source software that treats the entire data center as one machine. And that's the reason why there is an open source software from Mesosphere called DigitalOcean, an operating system for the entire data center. Even Kubernetes is going to almost act like an operating system for your entire data center. So they automate the distribution of applications. So you don't deal with one machine at a time, but rather submit the job. The job is nothing but take this application and run it in the pool. And that is going to be the job definition. You would submit it to the tools that manage the data center infrastructure, and they will figure out how to actually run the application in the most optimal form. So they act as the coordinator or the scheduler or the controller or the conductor by figuring out which slots are available in the data center and safely placing your application in one of these slots. And ultimately, the goal is to ensure higher levels of utilization and efficiency. Kubernetes is one of the most popular open source projects, almost as popular as Linux in the container world, because it is becoming the preferred data center management tool in the new contemporary world of containers. So let's understand that a little bit. So before we take a closer look at Kubernetes and understand the core components and the building blocks, let's visualize how the new data center would look like. So the physical infrastructure is not going away. We are not going to replace the physical servers, the storage and the routers and the network infrastructure. That is not going anywhere. It is structure that is handling compute, storage and networking capability. On top of the physical infrastructure. And these VMs are now going to be collectively treated as a set of clusters. And these clusters are logical isolations or logical partitions on top of the VMs. For example, you might want to run a dev, test, and production cluster. So the production cluster obviously demands more resources. So from the aggregate pool of resources, you would say run 70% of the pool for production. So production cluster will get the priority, and it has better access to the underlying resources because it is given that privilege as the production cluster. Similarly, you might want to have another cluster, which is a development cluster, and you don't need so many resources because it's only meant for internal development. There you might actually assign only 15% of your existing data center or your infrastructure resources, and remaining would go for, let's say, testing or QA. So that way you are able to take the aggregated pool of resources and effectively utilize them for a variety of scenarios. And later on, let's say during weekends, your production workload doesn't demand so much of infrastructure. Guess what? You can even effectively split the resources and create another cluster or resize existing cluster for better resources. And you can again go back to the original configuration when there is peak load. So these clusters are actually logical. They are not physical clusters. They are responsible for drawing a tiny thin line across your resources so that you have better control of the infrastructure. But who manages these clusters, and who will decide what application is going to run in which cluster? That's exactly where we have the cluster manager. So cluster manager, which is also called as an orchestration engine, has complete visibility into your infrastructure. At any given point of time, it precisely knows what are the available resources, what are the applications that are running in each cluster, and how should a new application get positioned. If your cluster manager is running in cloud with an auto scale infrastructure, it can even launch additional VMs to accommodate the newer applications. Now, in this new world, in the new data center environment, you take an application, package it in a different form, maybe using containers, and you submit the entire application with its resource definition saying databases give these many CPU cores, these many IOPS, these many this much of RAM, and you submit that to the cluster manager, and cluster manager will figure out where to place your entire application depending on the available resources. This is completely logical. This is not translated to a specific implementation, but think of cluster manager as your job scheduler. Now, if you're familiar with distributed computing, if you're familiar with Hadoop, in a lot of sense, this is like any other job scheduler. You basically package your application as a job, submit it to the cluster manager, let it figure out where to schedule, where to position your workload. So this is the new face of data center, and this is how you would deal with your modern infrastructure in the coming months and years. So what is the role of Kubernetes? Well, Kubernetes is actually the cluster manager or the orchestration engine. It came from an internal Google project called Borg. So Google, for a long time, for over a decade, has been using a similar architecture to run some of its web scale properties, including Google Search, Gmail, YouTube, and a variety of other web properties. So Google knows a thing or two about pooling the resources and managing them effectively. In fact, Google's internal project called Borg is all about optimally utilizing the infrastructure of a data center. So when containers started to pick up momentum, Google came out and announced an open source project, which is a subset of Borg, and it was named as Kubernetes. So Kubernetes is highly inspired by Borg. It is a version that has been made publicly available, optimize it for containers, and they reduce the complexity because they wanted this to be available to a variety of users, including at least startups, developers, and web scale companies. So they took a subset of Borg, refactored it, repackaged it, and that open source project is called Kubernetes. Kubernetes essentially exposes a unified API for deploying web apps, batch jobs like cron jobs, and even databases, which are stateful, durable applications. More on that later. And the job of Kubernetes is to efficiently decouple applications from the machines that they are running on. And how does it do it? Basically by creating containers as the deployment unit, and containers will abstract the underlying infrastructure. So Kubernetes effectively decouples your applications from the machines by managing the containers. And it also gives you a very nice declarative approach to deploying applications, which means you can open a text editor and say, hey, here is my container that runs the web app, and run 20 instances of this. And each instance would get X number of CPU cores or percentage of CPU cores, Y MB or GB of memory, and this is the storage requirement. So you'll actually declare a manifest of your application depending on their resource requirements and depending on their runtime requirements. And you throw this definition at Kubernetes and it will take over from there. It automates application configuration through service discovery. It might sound very loaded, but what it basically means is if you have a database running within Kubernetes and you have a web app running within Kubernetes, they need to talk to each other. They need to see each other. And that talking mechanism or seeing mechanism is technically called as service discovery. So your web app needs to discover where the database is and establish a connection. So Kubernetes has a very simplified mechanism for service discovery. We are going to cover this in depth in the next webinar where I talk about the building blocks of Kubernetes. It also maintains and tracks the global view of the cluster. What it means is at any given point of time, Kubernetes has 100% visibility into everything, from the physical infrastructure health to every running VM, every cluster defined on it, and every application deployed through Kubernetes. It has 100% visibility, and if something goes wrong, it knows how to handle that. For example, if a container is not healthy, it will attempt to relaunch it and it will restart the whole thing automatically. Similarly, if one of the nodes, which we'll discover, which we'll explore in the later slides, if one of the nodes is not healthy, it will launch another node and carefully relocates your application from one to the other. So it has complete visibility and it tracks the health of your entire cluster. It has APIs for deployment. For example, you can perform what is called as rolling update. So if you have a huge application that is running in Kubernetes and you want to selectively update a part of it and do a blue-green deployment, you can pretty much do that with one command from the command line interface of Kubernetes. There is a concept of canary deploys where you can have a mix and match of multiple versions and all of them will start receiving the traffic, and you can test these deployments independently. A combination of this in a specific pattern is called blue-green deployment, where blue is the current version and green is what you're going to deploy as a new version. And you can use Kubernetes to effectively perform those blue-green deployments where you split the traffic and carefully monitor the performance and the user feedback. So that is Kubernetes in a nutshell. Essentially, it is this blue block that you see, which is at the top of your infrastructure, which can manage the clusters, which can manage the underlying infrastructure, and of course your applications. So as I mentioned earlier, if you are familiar with any distributed computing architecture, including Hadoop, you would find this very familiar. So there are clients. Clients are the applications that actually submit a job to the master, and the master has visibility and manages a set of nodes. So you are going to be one of the clients. That means your machine is going to be one of the clients, and you will throw a job at the Kubernetes master, and the Kubernetes master will parse this job definition, figures out what needs to be done, and carefully places your application in one of the available nodes. It might actually sound very simple, but it is architected to make it simple, but behind the scenes, Kubernetes does a lot of magic to make this and to keep this simple. So let's take a closer look at the master nodes and the worker nodes. So at a high level, Kubernetes has 3 to 4 building blocks, right? The core foundational aspects. You need to have a private registry or a public Docker registry that's available to your Kubernetes infrastructure. So the colored blocks that you're seeing there are container images. If you have attended my previous sessions, you remember Docker commit, Docker tag, Docker build commands through which we were able to create images, and using Docker push, we were able to push it to private registry or to the public registry running on the Docker hub. Irrespective of where your registry is, you need to have your images accessible to the Kubernetes infrastructure. So that is the fundamental element of our architecture. Then, of course, there is a Kubernetes Master, and then it can talk to a set of nodes. And this Kubernetes Master exposes an API, like any other distributed computing environment. And this API is going to be consumed by the UI, which is actually available through the dashboard interface. Kubernetes comes with nice dashboard, which is an add-on, but most of the distributions have this pre-installed. So the UI and the CLI will create a job definition, which is nothing but a manifest of your application. These color-coded icons that you see here, basically they are reflecting or they are associated with a set of images running in the Docker registry. So you create those definitions as simple YAML files and you submit them to the Kubernetes master, and they will ultimately make it to one of the nodes. And nodes will talk to the Docker registry to pull appropriate Docker images, and they will instantiate those images to make them as runtime containers. So taking a very close look at the Kubernetes master, at the bottom you have a distributed key value database, and it is called XD. XD, think of it as the distributed key value store, which is accessible to every component of the Kubernetes master. For example, at any point of time, if Kubernetes master wants to find out how many nodes, how many worker nodes are in the cluster, it will ask XD. And XD will have a key value, number of nodes, followed by an X, and it will immediately become available. Similarly, what are the available resources? XD has that as a key value pair. How many workloads are currently running? How many clusters do we have? So XD has the complete snapshot of your cluster at any given point of time, and it is going to be the single source of truth for the entire Kubernetes infrastructure. So that is going to be the backbone for every component of Kubernetes master. So once XD is set up and it is populated with the current snapshot of your cluster, then there is an API server. So the API server, as you can expect, is nothing but an endpoint that can scale. So the API server is responsible for exposing the secure API endpoint through which the clients will talk to the cluster. It is like any other API server that you might want to expose, except that this is highly optimized to deal with the Kubernetes API. Then you see the yellow block, which is called the scheduler, and the scheduler's job is to take the job definition in a YAML file, figure out what are the requirements that are defined in the manifest in your YAML file job definition, and then ask XD to tell what is the available infrastructure, what are the nodes that are capable of running the containers that you want to deploy, and scheduler will decide which node is going to run your application. And then it hands over the control to what is called as a controller, and controller is ultimately going to deploy the application and will start maintaining the health, and it ensures that at any given point of time the application has the desired configuration state. For example, you might want to run your web application, your web front end in 20 containers. So you want to run that as 20 instances. Similarly, you might want to expose the API endpoint of your application, and you want to run 10 instances of it at any given point of time. Whose job is it to make sure that at any given point of time your web app is running in 20 instances, and your API endpoint is running in 10 instances, it is a controller's job. So the controller will ensure that depending on the definition of your application is running in the same exact configuration. After launching 20 instances, if one instance goes down for some reason, controller's job is to immediately bring it back to the desired state by launching another container and to ensure that the count is always 20. So controller will maintain the desired state of configuration for the entire cluster, and scheduler plays the role of a conductor by querying HD and figuring out where to place your container workload. So that's it. These are the core building blocks of a Kubernetes master configuration. We have HD, which is the key value database, which is going to be a distributed in-memory database to maintain the state of the cluster. API server to expose the API endpoint through which you can submit jobs to the Kubernetes cluster. Scheduler will make a call on where to position and place your application, and controller will constantly monitor your application to ensure it is meeting the desired configuration state. Then let's take a closer look at the node. So once the master decides, within the master, it is the scheduler that decides your application, which is a collection of containers. And we are going to take a closer look at this in the upcoming sessions. But for now, a pod is like a deployable unit in Kubernetes. So a pod can contain one or more containers. So you take your code, you package it as a container, and you can run it with the Docker run command. But if you want to run that in Kubernetes, you got to package that container as a pod, and a pod can contain one or more containers. So there is a reason why containers are packaged as pods. We'll explore that in the upcoming sessions. But for now, think of pod as a deployable unit within Kubernetes. In many cases, in most of the cases, a pod contains only one container. But even if you're running just one container, it still needs to be packaged as a pod. So when a pod definition is submitted to Kubernetes Master, it is going to be deployed. It is going to be scheduled on one of the Kubernetes nodes. It's actually called as a worker node. And this worker node has certain components. For example, let's start with kubeproxy. So kubeproxy is an element running within a node, which is responsible for the networking aspect of Kubernetes nodes. It creates an overlay network. It creates a flat networking space through which pods running on any node can talk to each other. It does many more things other than enabling pod-to-pod communication, but for all practical purposes, kubeproxy is the networking agent running in every node. Then there is a kubelet, and kubelet's job is to report the current state of the node to the master. So it maintains the dialogue with the master. And of course, if you want to run containers, you need Docker. So there is Docker, and both kubelet and Docker are optionally packaged in a surrogate process called supervisor D. I'm not going to get into the details of supervisor D, but if you come from Linux background, you know that it is a surrogate process where you can actually create multiple executables and wrap them under one process. So supervisor D will ensure that if kubelet dies, it will automatically bring back. And if Docker dies for some reason, supervisor D can bring it back. So you are basically creating a wrapper on top of Docker and kubelet and running it as one super process. And that is what supervisor D all about. FluentD is basically the logging agent. So it is going to ship the logs from the node to the central location. It could be any other infrastructure that, for example, you might want to set up an Elk stack and ship all the logs from all the nodes. So you can configure FluentD to talk to the centralized log aggregation engine. It is basically meant to make sure that you are collecting the logs generated by your nodes, by your containers, and your applications. And then we have some optional add-ons like DNS. So DNS makes it easy for you to discover the pods by their name. You can also actually not the pods, but services, which we're going to explore in the upcoming webinars. But for now, think of DNS as an internal private DNS exclusively set up for Kubernetes so that applications can discover each other and can use a well-defined naming convention. Optionally, you could also run the dashboard, which is the UI, which I have briefly touched upon. It is going to consume the API and provide you a nice user interface to access the Kubernetes infrastructure. So to summarize, the node is actually the workhorse where containers run. If you look at the master, no containers are scheduled on the master. It is not supposed to run the applications, but manage the applications. The actual workhorse of a Kubernetes cluster is a node. This is where the action takes place. This is where containers are scheduled as pods, and you can run multiple pods on each node. So how do you get started with Kubernetes? So now that we have seen the high-level architecture, that Kubernetes has a master node and a worker node. Master exposes the API, node runs the actual workload. Now, how do we actually install? Well, there are two ways of setting up Kubernetes on DigitalOcean. The first one is the Kubernetes the hard way. If you really want to test the waters and you want to learn the end-to-end configuration, I would strongly recommend you to explore this. Interestingly, we covered this about a year ago. The short links that you see here, they are pointing to a step-by-step tutorial that I have published at the new stack. So it has a complete step-by-step command line guide for you to copy and paste and pretty much set up a multi-node Kubernetes cluster on DigitalOcean. If you want to follow through a video tutorial, this is again a DigitalOcean webinar that's uploaded to the YouTube channel of DigitalOcean. You can actually access this bit.ly/DOK8S video. You can actually access this, play it back to learn all the steps, and side by side you can also keep this open and copy and paste the commands, and in about 15-20 minutes you actually have a working cluster. So this is the hard way, and it requires you to understand the nuts and bolts of DigitalOcean's infrastructure, the way the private networking works, and if you want to add block storage and load balancers, you can do all of that. It gives you a lot of control, and you get into the deeper configuration techniques and basically building a cluster end-to-end all by yourself. But if you are looking for an easy option, you're not an administrator and you don't want to get your hands dirty, but very quickly have the Kubernetes cluster running on top of DigitalOcean, you can sign up for a 30-day trial at stackpoint.io. So Stackpoint is one of the managed Kubernetes providers, and it's a multi-cloud deployment control plane. So you can choose one of your favorite cloud platforms, including DigitalOcean, click a couple of buttons, and in about 15 minutes, you have a fully configured cluster at your disposal. And if you are not a systems administrator and you're not familiar with running the command line interface and the command line tools, you can switch to Stackpoint, and all you need to have is a valid DigitalOcean account, and Stackpoint will do the rest. So in about 15 minutes, you'll have a full-blown, fully configured cluster that you can start using. So that's all about the background, the architecture, the evolution, and the theory. Now it's time for us to take a closer look at the actual steps to install Kubernetes. So let me walk you through that. All right. So this is my DigitalOcean interface, right? So I have already logged in, and like most of my demos, it's a blank slate. I don't have any droplets. Now our goal is to run a Kubernetes cluster with a couple of worker nodes and one master node. So we start by accessing stackpoint.io. So let me actually log out and let me start from the scratch, right? So this is how the interface looks like. So you click on login, and then you can use one of the authentication providers. I was pretty impressed to see DigitalOcean. So if you're already a valid user and a valid customer of DigitalOcean, you need not sign up with different credentials. You can actually use DigitalOcean's credentials to log in. And because I have already logged on in the other tab, it directly takes me to the next page. And these are the platforms supported by StackPoint, and you can access DigitalOcean. So it is pretty straightforward. So all you got to do is select this, and then you'll be shown a couple of settings. So here you have the workspace, right? You need not change any of these details. So you can, if you have a custom API token from DigitalOcean, which is required for you to use doctl, the command line, or any third-party application that can manage DigitalOcean, you can add the custom API. And if you authorize StackPoint, it can go ahead and create its own DigitalOcean token. Similarly, if you want to have a custom SSH key, you can click this and copy and paste your public key. And that's going to basically make sure that your Kubernetes cluster is using a custom SSH key. Of course, you need to have the private key. Without that, you cannot access. My suggestion is to leave the defaults. The only change that you may want to make is to click on the edit cluster here. You can choose how many masters you want and how many workers, and then choose the region. So you'll see all the locations, all the regions supported by DigitalOcean. I'm very excited to see Bangalore. So I'm going to select that and update. By the way, if you want to update the number of worker nodes, you can always increase this, but remember, it's going to result in a new droplet, which means you'll end up spending more. So if you know what you're actually doing, select one of those options and change the number of worker nodes. But I would recommend you to leave this to just 2, particularly if you are learning Kubernetes. This is a good configuration, and click on update. So now what we have done is basically made the cluster to get deployed in Bangalore. That's all. That's the only change required. And then click on submit. This is going to take you to another page. Here you need not touch anything. For example, the only change that you might want to make is to give a name, which is your custom name, which is easy for you to remember. So I'm giving the DigitalOcean's symbolic representation, which is SAMI. So SAMI-K8S is the cluster name that I'm choosing. If you want, you can modify the version of Kubernetes. Install dashboard. This is the add-on. This checkbox will get our dashboard in place. Role-based access control is a value add from StackPoint. You can also change what kind of distribution you're using. For example, you can switch between different versions of CoreOS, or you can choose Ubuntu. But again, you need not touch this. If you're a newbie who is trying to get familiar with Kubernetes, don't make any changes here. It's not required. Then click on submit. That's it. Now, once you submit the request to StackPoint, what it does is it will kick off the entire cluster installation process. So here we have created a cluster called SAMI Kubernetes. Workspace is default. Version of Kubernetes is 1.8.5. And kubeconfig, I'll come to this in a minute. That is going to be our configuration for accessing the cluster. Provider is DigitalOcean. 3 nodes, 1 master, 2 nodes running in Bangalore, running on CoreOS. And this will show you the actual status. So currently it is showing us building. And you can later on, you can actually modify this, or you could also get rid of this cluster. If you want to clean up, you can click on delete. Now, this is going to take a good 10 to 15 minutes. If you are doing it all by yourself, it's time for grabbing a coffee and staring at the screen for about 10 minutes or 15 minutes. And then this will be ready at some point, indicating that the cluster is now accessible. To save time, I have gone ahead and configured exactly the same configuration, the same cluster, exactly the same set of configuration settings, no change. So after the entire cluster is available, you will actually notice that this switches to running. And this will indicate this would indicate that we are actually running a Kubernetes cluster on top of DigitalOcean, and it is currently available in its final form. So this is an indication that everything is up and running. So All right, so I'm getting a few pings from the panelists, so I want to make sure I'm covering some of those things. So basically, I want to establish the relationship between DigitalOcean and StackPoint. So StackPoint is a third-party control plane which will target the deployment of Kubernetes. Now, once you have gone ahead and set up the Kubernetes cluster through StackPoint, you will actually realize that it shows up in your DigitalOcean account, right? For example, here in this deployment, I have one master and two worker nodes, and you'll be billed for this, right? And similarly, StackPoint has a different pricing. You can actually go ahead and explore its pricing model. But the good thing is StackPoint will give you a free cluster for 30 days. So if you are learning all about Kubernetes, it's a very simplified mechanism for you to get started in the cloud. There are other mechanisms, but I would strongly recommend that you try this on cloud so you actually get to experience the scale and the production-like environment. So now the cluster is up and running, and it's time for us to access this. So how do we actually do that? Well, click on the cluster name. So SAMI Kubernetes, click on this, and you will see there is something called kubeconfig. All you got to do is download this. So once this is downloaded, you also need to set up what is called kubectl. So kubectl is the command line tool that you can install. You can actually get kubectl from the Kubernetes distribution, or there are multiple mechanisms of getting kubectl. You can also use Homebrew if you're on a Mac. It doesn't matter how you install kubectl. There are a couple of mechanisms. So you can actually grab the kubectl and then download kubeconfig to your local machine. And after that, you're all set to use the Kubernetes cluster. So I have gone ahead and downloaded kubeconfig. So how do we actually use this? Well, you got to set the configuration by creating a command line environment variable, which is called kubeconfig, and set this to the actual location of the configuration file that you downloaded. In my case, I have just left it in the downloads folder. So once you export this environment variable and installed kubectl, this is going to give you access to the Kubernetes cluster. So kubectl version is an interesting and useful command that tells you what is the version of the server, which is actually the StackPoint Kubernetes cluster running on DigitalOcean. And this is the client version, which is the command line interface called kubectl. Perfect. So now we have the kubectl, the command line tool of Kubernetes, talking to our remote cluster running in DigitalOcean, set up by StackPoint, deployed in the Bangalore region. Perfect. Now we are ready to use our Kubernetes cluster. So you can actually run a couple of commands. Again, this is the very first session in the Kubernetes part of the webinar series. I'm going to cover more of the command line and what you can actually do with it in the upcoming sessions. But for now, our job is to make sure that the cluster is installed the right way and it is ready to run our application. So we'll do a simple set of, we'll perform simple set of steps to ensure that the cluster is available to us. So we can actually run what is called as cluster info. So this command will show us the current status of the Kubernetes cluster. So Kubernetes Master is running at this location. Heapster is one of the components of the Kubernetes cluster. More on that later. kubedns is the DNS add-on, which is already installed, and everything is green and everything looks good. So that's an indication that the Kubernetes cluster is perfectly configured. After this, the next step is to actually see how many nodes we are running. So kubectl get nodes will show us there is one master and there are two workers. I set this up 3 days ago. So it's showing the age of the cluster with the version of Kubernetes. The latest version is 1.9, but 1.8.5 is one of the very recent builds. So it is as good as the most current one. So with the Kubernetes cluster available to us, it's time for us to actually run an application, right? So I want to run a very simple Nginx web app. So I want to introduce you to a command called kubectl run. This is almost similar to Docker run. You know, we are not packaging this into a pod. I'm not taking the long form mechanism of deploying an app. Instead, I'm taking the shortcut by using this command called kubectl run. So all I got to do is just point it to the image and give it a name, right? So I'm going to call this my web. So kubectl run -- image is equal to Nginx, and name of this deployment is called my web. Now this is going to take a few seconds and says deployment my web app created, right? We can verify this by running another command called kubectl get deployments. So a deployment is essentially a collection of containers, which comes with a desired state. Again, don't worry too much if you're not understanding what a deployment is. I'll cover that in the later sessions, but for now, a deployment is a configuration which will ensure that your application is always running in the desired state. All right, so now we can check the application running. So now you'll notice that there is my web followed by an arbitrary identifier and its status is running. So this is pretty interesting. You can also use a command called kubectl logs and copy and paste this pod name. It doesn't show any logs because we don't have anything yet running in it. So kubectl is the command line interface. Now it's time for us to actually access. So before I access the web app, I need to expose this. So I want to introduce another command called kubectl expose, and we are going to tell that we are exposing a pod, and this is the name of the pod. The port on which the container is listening is port 80. The actual port that is going to be made available within the cluster is also port 80. And I want to expose this as a node port. Again, these are all the primitives of Kubernetes. At this point, don't worry if you are not able to understand why I'm using type node port. It is basically a mechanism for us to expose the Nginx pod, Nginx container packaged as a pod, across all the nodes of our Kubernetes cluster. So when I actually run this, it is going to create what is called as a service. So now we can verify this with the command kubectl get services. And now this is actually running as a node port service. And this is the port through which we can access this on our nodes. So let's test this from the command line. So first I go to one of my nodes. I'll grab the public IP address, come back, curl this IP with this port, and we should actually see Nginx. Perfect. We can also access this from the browser, of course. So you can grab this and access it from the browser. So the best thing about using a node port is you can actually grab another IP address of another worker node, copy it, and then grab the port number, and we'll again see the same. The IP addresses are different. This is ending with 214. This is ending with 7. But because we position this service as a node port service, it is pretty much available on any node as long as the port number is the same. That's the reason why I created this as a node port. You could also create that as a load balancer, in which case StackPoint may spin up a DigitalOcean load balancer and front ends that with your service, and you can always use one IP address of your load balancer to access this. But again, I don't want to complicate things further, but the good thing is we have gone from 0 to 60 in less than 10 minutes. From a blank DigitalOcean interface, to running 3 nodes, 1 master and 2 worker, all in less than 10 minutes. And then I've also shown you how to access this from the command line. Now grab kubectl, the latest version of it, and after that you can run a series of commands, and you can deploy your hello world equivalent of an Nginx or an Apache and test it. All the steps mentioned here are pretty much available in the tutorial, which will go live in a couple of days. You will receive a link, and you can always check the URL, which is devo.co/webinars, and you can access the tutorial. All right, so it's time for me to summarize what we have learned in this session. So Kubernetes is an orchestration manager for containerized workloads, which means it is going to run like an operating system for your data center. It can deploy applications on any VM, any machine available in the data center, and it treats your pool of machines as one huge infrastructure unit. Master nodes act as the control plane managing the cluster. Remember those things: etcd, the key value database, the API layer, the scheduler, and the controller. That's what is making the master nodes. Then you have worker nodes, which are the workhorses. They run the containers packaged as pods. Pod is a deployable unit of Kubernetes. A pod may contain 1 or more containers. Kubernetes can be installed manually the hard way. If you want to really get into the dark, deep details of how to do it, you can refer to the tutorial link that I have shared, or you can set up the cluster with 2 clicks using stackpoint.io. And once the cluster is up and running, you can use kubectl to talk to the cluster. And by running those 3 commands with kubectl run, kubectl expose, and kubectl get services, you can very quickly access the app that you deployed. What commands do you need to learn from this session? Well, kubectl cluster info, I have shown you this. Kubectl get CS is getting the component status. You can explore it on your own. I didn't show it because this is something that I want you to explore. It will show you the health of the entire cluster. You should go ahead and explore that. Kubectl get nodes will show you a list of nodes. Pretty much what you see in your DigitalOcean console will be what is shown in the command line. So it actually matches the count. Typically 1 master with 2 worker nodes if you leave the stack point default configuration. Kubectl run takes an image name and the deployment name and immediately runs an application. Kubectl exposes the app that you ran with kubectl run command to the outside world if you expose it as a node port or load balancer. And then, of course, kubectl has a command called delete, which will let you delete the deployment. And you can explore this by looking at the command line help or the manual. So you can take kubectl delete and delete the service that you exposed, the deployment that you created, and clean up all the resources with the delete command. So again, the details of all these commands are very clearly documented and explained in the tutorial. So do watch out for the tutorial to become available. So that brings us to the end of this session. Like most of my sessions, I had lots of fun. I love demonstrating technologies in my sessions. It's a bit of risk, but I absolutely love to take that risk and show you live demos. And I'm so glad it all worked really well and everything worked the way I wanted it to work. So I hope you found this useful.